In this video, we will review on key concepts of numbers and operations that you need to know for the SAT. Let's start with real numbers. All numbers on the SAT are real numbers. Real numbers include the whole numbers, the integers, rational numbers, and irrational numbers. So whole numbers are also known as counting numbers, and these include 0, from 0, 1, 2, and so on. While integers are positive and negative whole numbers and the number 0. Rational numbers are all numbers that can be written as fractions, terminating decimals, and repeating decimals. Rational numbers also include integers. So these are the examples of rational numbers: 3/4, 0.25, or 0.333. The irrational numbers are numbers that cannot be expressed as terminating or repeating decimals. Say, for example, square root of 2, pi, or 1.606695, and so on. Okay, let's say, for example, you're asked to identify this number, negative 17. So negative 17 here is an integer because it is a negative whole number, but it is also a rational number because it can be written as a fraction, as negative 17 over 1. And take note that all integers are also rational numbers. Now let's go to comparison symbols. These are the symbols. And this one, the first one, means equal to. Say, for example, 5 is equal to 5. So the number on the left is equal to the number on the right. And the next symbol, this one, means is not equal to. Say, for example, 5 is not equal to 6. Then the next one is greater than. So for example, 5 is greater than 4. Then this one is greater than or equal to. Say, for example, y is greater than or equal to 3. This means that y can be 3 or any number greater than 3. Then the next symbol is this one, means is less than or is less than. Say, for example, 2 is less than 3. Then the next one means is, less than or equal to. Say, for example, y is less than or equal to 5. This means that y can be 5 or any number less than 5. Say, for example, if x is greater than 50, which of the following is a possible value of x? So this, the value of x here is greater than 50, which means we look for numbers that are more than or greater than 50. And we have choices here, options here. Let's take a look at negative 53. Negative 53 is a negative number. Of course, that is, this one is less than 50. So this cannot be, as well as negative 47. How about these three positive numbers? 38 is definitely less than 50. 50 is just equal to 50. So the best option here or answer is letter E, 51, which is greater than 50. Now let's go to symbols of multiplication. So when we say factor, a factor is a number that is multiplied, while a product is the result of multiplication. Say, for example, we multiply two numbers. Let's say 5 times 6 equals 30. 5 and 6 here are full factors, while 30 here is the product. And you can represent multiplication in the following ways. A multiplication sign or a dot between factors indicates multiplication. So we can write as 5 times 6 equals 30, or 5 times 6 equals 30. A parenthesis around a factor also indicate multiplication. So we can write this as 5 times 6 equals 30, or 5 times 6 equals 30, or parenthesis to both of the factors. And take note that multiplication is also indicated when a number is placed next to a variable. Say for example, 6a. 6a here can be written as 6 times a. Let's say for example, we're given this problem. If x is equal to 5 minus 3, what is the value of 5x? So 5x here means 5 times x. Let's just use the dot here. And it's given here that value of x is 5 minus 3. So we can just plug in the value of x to the given expression. So this would become 5 times 5 minus 3. And 5 minus 3 is equal to 2. Then 5 times 2 is 10. Therefore, the best answer here is letter E. Now let's go to like terms. So we have terms here, variable and coefficient. When we say variable, variable is a letter that represents an unknown number. And variables are used in equations, formulas, and mathematical rules. And a number placed next to a variable is the coefficient of the variable. Let's say, for example, we're given this expression or term 8c. So 8 here, change that. 8 here is the coefficient to variable c. So c is the variable. How about we're given this expression or term 13xy. So 13 here, this one, is the coefficient to both variables x and y. And if two or more terms contain exactly the same variables, they are called or considered like terms. Say for example, 2x, 3x, 50x, should be 50x, 100x. Okay, these are all like terms. And another example, let's say negative 5xy, 6xy, xy. These are like terms too. And take note that variables with different exponents are not like terms. Say for example, these two here, 5x cubed y and 3xy cubed. These are not like terms because they don't contain exactly the same variables. X here, we compare x, the variable x in these two expressions. X here has an exponent of 3 while here has an exponent of 1. So they are not like terms. And you can combine like terms by grouping using mathematical operations. Say for example, 2x plus 8x equals 10x. So since they have the same exactly contain the same variables, then you can just add up the coefficients 2 and 8. So 2 plus 8 is 10. Then you copy the variable x. And for the second example, 20x minus 10x, you just have to subtract the coefficients 20 and 10. So 20 minus 10 is 10. Then you copy the common variable. Okay, for example, we're given this problem here. Which of the following is equal to the expression above? So the given expression here is this one, and only like terms can be combined in this expression or in any expressions. So let's check the common or the terms that are alike. 7xy goes with 9xy, then 5y goes with 6y, and the rest they don't have like the rest of the terms, they don't share the same variables with the others, so we can just leave them as they are. We can just copy this one, 4x squared y. Then we combine 5y and 6y, so we add them up. 5y plus 6y, so this is 11y. So plus 11y. Then we combine 7xy and 9xy plus 9xy. They are like terms, so we just add up the coefficients 7 and 9, which is 16. 16xy. So this is plus 16xy. Then we copy the rest of the terms. 8x plus 3x y squared. Then we can arrange this based on the degree or the exponent. So we can rewrite this as 4x squared y plus 3x y squared plus 16xy plus 8x plus 11y. So the best or the expression that is equal to the original expression above is letter A. Now let's go to the properties of addition and multiplication. So these are the properties: commutative property of addition, commutative property of multiplication, associative property of addition, associative property of multiplication, and the distributive property. So what is commutative property of addition? So when using addition, the order of the addends does not affect the sum. Say for example, a plus b is just equal to b plus a. Or let's say 5 plus 6 is just equal to 6 plus 5. How about the commutative property of multiplication? When using multiplication, the order of the factors does not affect the product. Say for example, a times b is just equal to b times a. Or 5 times 6 is just equal to 6 times 5. Then we have the associative property of addition. When adding 3 or more addends, the grouping of the addends does not affect the sum. Say, for example, a plus b plus c is just equivalent to a plus b plus c. Or let's say we're given 4 plus 5 plus 6. This is just equivalent to 4 plus 5 plus 6. Then how about the associative property of multiplication? When multiplying 3 or more factors, the grouping of the factors does not affect the product. Let's say we're given 5 times AB. This is just equivalent to 5A times B. Or say for example, we're given 7 times 8 times 9 is equal to just 7 times 8 times 9. But how about the distributive property. In distributive property, when multiplying a sum or a difference by a third number, you can just simply multiply each of the first two numbers by the third number and then add or subtract the product. Say for example, 7 times a plus b. Then we distribute 7 to a and b. Then just copy the operator sign, in this case plus. So this is 7a plus 7b. Let's say we're given 3 times 4 plus 5. So we just distribute 3 to 4 and 5. So 3 times 4 is 12 plus 3 times 5 is 15. Okay. How about we're given this one? Let's say 9 times a minus b. Then we just distribute 9 to a minus b. So 9 times a is 9a. Then copy the operator sign minus. Then 9 times b is 9b. Let's say we're given this problem. Which equation illustrates the commutative property of multiplication? So recall that in commutative property of multiplication, when using multiplication, the order of the factors does not affect the product. Let's take a look at the options here from A to B. So option A here, of course, this is not commutative property of multiplication because you distribute 7 to the expression inside the parentheses. So this one is distributive. How about letter B? So letter B here, we multiply the factors. But then take note, even if you group the two numbers here, they don't affect the product. So this one is the commutative property of multiplication. Letter C here is also distributive. Then letter D here is associative property of multiplication, as well as letter E. So this one is associative. Now let's go to the order of operations. So you must follow a specific order when calculating multiple operations. And we use the acronym PEMDAS, or the mnemonic. So you can use please excuse my dear on so P here stands for parentheses. We first perform all operations within parentheses. Then E here is for exponents. We evaluate the exponents next. Then we have multiplication and division. So we multiply and divide. Then we work from left to right in our multiplication and division. Then the last ones are add and subtract. So lastly, we work from left to right in our addition and subtraction. Say for example, this problem, 8 plus 4 times 3 plus 1 squared. So we perform the expression inside the parentheses first, the 3 plus 1 squared, that would become 4 squared. So this is parenthesis. Then the next one, exponent, 4 squared, that would equal to 16. Then multiplication and division. So we can perform 4 times 16. Then we have 64. So this is multiplication or division. Then lastly, we have addition or subtraction. We get this answer. Let's say you're given this problem. Okay, what is the value of the expression above? Now, following the order of operations, this expression here can be simplified as, okay, the first thing we do is we solve or perform the expression inside the parentheses. So this would become 3 times 49 minus 16 is 33, plus 5 times 2 plus 3 squared. So we perform 3 squared first. So that is 2 plus 9 minus 6 minus 4, that is 2 squared. And this would become 3 times 33 plus 5 times 2 plus 9 is 11 minus 2 squared is 4. Then we can perform this first, the multiplication. 3 times 33, that is 99, plus 5 times 11, which is 55, minus 4. Then we do the addition and subtraction from left to right. So 99 plus 55 minus 4, this would give us a value equal to 150. Therefore, that expression is equivalent to 150. Now, this is just the first part of numbers and operations, and I will discuss more on this in the next videos, such as powers and roots, laws of exponents, squares and square roots, perfect squares, properties of square root, radicals, and so on.